Hey guys, in this video we'll be talking about balanced and unbalanced forces. So let's just write our heading here. Now, first of all, let's see what is an unbalanced force. An unbalanced force basically means that there is a net force. Let's just see an example of an unbalanced force. For example, this is a mass. Let's say it's 10 kilogram mass, and I'm pushing it with a force of, let's say, 200 newtons. Now you can see, if I use the formula F is equals to ma, there is a net force. In this case, the net force is 200 newtons. Since there is no other force, the net force is 200 newtons. And I can simply find out the acceleration using this formula. So 200 divided by 10, the acceleration would give me 20 meters per second square in the direction of the net force. This is obviously in the direction of the net force. This becomes 20 meters per second square. Let's see if this is the simplest example of an unbalanced force. This means that there is a net force acting on this box, and there is an acceleration, a net acceleration, or a total acceleration of 20 meters per second in a direction. Let's take one more example of an unbalanced force. Let's see. If we have a mass here of 20 kilograms, and we have a force in this direction which is 20 newtons, and in this direction which is 10 newtons. Let's see the net force. So for the net force, we'll have to make our arbitrary axis, and I would take the right hand side as positive and the left hand side as negative. So for net force, I will have to sum two forces. This would become plus 20, since it's in the towards the right hand side, so this would become plus 20, and this would be minus 10. So my net force would simply be 10 newtons. So I do have a net force. Whenever I have a net force, this shows that these forces are unbalanced. And let's find out the acceleration. We can simply find out the acceleration by the same formula. F net is equals to ma. So F net here is 10, and let's just divide it by the mass to get the acceleration. So the acceleration would be 0.5 meters per second square in the direction of the net force. Now the direction of the net force was towards the right, since this was a plus 10 newtons, and plus means towards the right. So this was 10 newtons towards the right. Whenever you are writing the force, you either mention the plus sign or the minus sign, or you tell, if you're not mentioning the sign, just tell them the direction of the force. You should write 10 newtons towards the right. So you can do either of the two. Now the acceleration would obviously will be in the direction of the net force towards the right. This would become 0.5 meters per second square in this direction. So again, there is a net force and there is a net acceleration. This means it's an unbalanced force. However, let's take a case here. Let's say if this is a mass of, say, 10 kilograms, and there is a force of 10 newtons in this direction, and a force of 10 newtons in this direction. What would this mean? Let's see. Let's find out the net force. Okay. Let's take this as positive and this as negative. Right hand as positive and left hand as negative. So when we are finding out the net force, it would simply be plus 10 right hand side minus 10 towards the left hand side. So this would become 0. The net force becomes 0. So there is no net force. There is no force acting on this box, because this force, if I let me just write the example here. Because this force is being nullified by this force. This force is cutting the effect of this one, and the net force comes out to be 0. It is as if there is no force acting on this box. Let's find out the acceleration. So for acceleration, we use the formula F is equals to ma, and if we want to find the acceleration, we simply divide F by m. In this case, the net force is 0. The mass is 10 kilograms. The acceleration becomes 0. 0 divided by anything is 0. So the acceleration is 0 meters per second square. This situation is called a balanced force, where the net force becomes 0. The sum of all the forces is 0. This situation is called a balanced force. These are called balanced forces. Because there is no net force, this 10 newtons is balancing this 10 newtons completely. And in the cases of a balanced force, or in these situations, since the net force is 0, there is always no acceleration. This means that we know from our kinematics that when the acceleration is 0, either the box is moving at a constant velocity, or it is at 0 velocity or at rest. We are not sure which one is the case in this one, but one of the two cases would be applicable here. Either if when the acceleration is 0, either the box would be moving at a constant velocity and not accelerating at all. That would mean that the acceleration is 0. Or the box is at rest. In that situation, there is a 0 velocity. So let me take one more example of a balanced force. Let's say this is the mass of 10 kilograms here, and here we have at 20 newtons in this direction, another person pulling it with a 10 newtons here, and here we have a 30 newtons. So let's find out the F net of this situation. Let's make our arbitrary axis. We say the positive is on the right hand side and the negative is on the left hand side. So now let's find out the F net, or the net force. This would just simply be the sum of all the forces. This would be plus 20, plus 10, and definitely we'll be adding it, but this would be plus minus 30. So plus minus 30 would mean a minus 30. So eventually this would mean plus 20, plus 10, minus 30. This is plus 30 minus 30, which means 0. So a net force here in this case is 0. This means that it is as if there is no force being applied on this box, because this 30 newtons in this direction is nullifying the 30 newtons in this direction. Because they are in opposite directions, they can nullify each other, and therefore there is no net force. So in this case, if we find out the acceleration, again F divided by m gives us acceleration by the same formula, F is equals to ma. So acceleration would be 0 over 10, which again is 0 meters per second square. This means that this box is not accelerating. So either this box, and whenever we have a case of zero acceleration, either the box is at a 0 velocity or at rest, or the object is moving with a constant velocity. So if its velocity is 2 meters per second here, its velocity would be the same here. So guys, these are balanced forces. I hope you understood this, and we'll be talking more about this when we'll be discussing air resistance. So stay tuned to it.